Count me down. I now call to order the Society's 2,409th meeting in the 149th year since its founding on March 13th, 1871. Good evening, everyone.
Good evening.
My name is Larry Milstein. I am the president of PSW, one of the oldest scientific societies of Washington, D.C., committed to providing a forum to further scientific understanding and inquiry. Welcome to our members and guests to tonight's planet definition debate between Ron Ekers and Alan Stern in the John Wesley Powell Auditorium of the Cosmos Club in Washington, D.C., including our members and friends around the world who are watching the live stream of tonight's meeting on PSW Science's YouTube channel. We will begin with a few announcements, as usual, but in the interest of brevity, we will forego reading of the minutes of the 2,408th meeting and the lecture on vaccines to combat the opioid epidemic by Kim Janda. Instead, we will turn directly to this evening's lecture. There will be a question and answer period after the debate. Following the Q&A, I will present a small thank you gift to our speakers. We will then have an audience vote on the definition they prefer. You will, for that vote, be permitted to violate the Cosmos Club rule against cell phones. You will need your cell phone to participate in this vote. I will give you instructions later. Finally, I will make a few closing announcements and adjourn the meeting to the social hour. Please join me in thanking the sponsors of the 2018-2019 lecture series, the Policy Studies Organization in cooperation with the American Public University, and a generous donor who's asked to remain anonymous. And also, please join me in thanking the sponsor of tonight's lecture, PSW member Jeannie Shaw, who is here today in the front row. She is sponsoring the lecture in memory of her dear friend and longtime PSW attendant, Karen Shaner. I'm pleased to announce that Ron Ekers has been elected to membership in the Society. I would say Alan has been too, but he is already a member. Please join me in welcoming Ron to membership. Ron? We have for Ron, and also actually for Alan, if he wants one, a signed copy of Volume 1 of the Bulletin of the Philosophical Society of Washington, covering the period from March 1871 to June 1874, and relating to us, the original members, and their reasons for founding the organization, and why they decided to call it the Philosophical Society of Washington. There's also an interesting article on how to calculate pi to 30 places by hand. As mentioned above, to provide as much time as possible for tonight's lecture, we'll forego reading the minutes of the previous meeting. So we now turn to tonight's lecture, which is tonight's planet definition debate. We should note that the Society has a long history of welcoming opposing viewpoints on the scientific topics of the day. We note the debates on the ether that took place before the Michelson-Morley experiment, and the long-standing and unfortunately acrimonious debate between Alexander Graham Bell and Edward Gallaudet on sign language and technique, on the role of sign language in deaf communication. Today's debate is in keeping with that tradition, and it is a pleasure to introduce our two debaters, Ron Ekers and Alan Stern, and to say a few words to start off the debate. So first, a note on the format. This is to be a friendly debate between our two speakers, centered on two different definitions of the scientific term planet. It will proceed according to a formal debate format. Each speaker will be on the stage for 20 minutes to make their main presentation. First Ron, then Alan, by agreement. They will then have the stage for 10 minutes each to make replies and closing remarks. Again, first Ron, then Alan. When Alan has closed and the debate is ended, we'll have a question and answer period. Questions directed to a specific speaker will be answered by that speaker first, and then the other speaker will be afforded an opportunity to comment as appropriate. Questions addressed to both speakers will be answered by both as they wish. We'll try to alternate who goes first as seems appropriate and as they may agree. After the Q&A, we'll thank our debaters, and I will present them with a small thank you gift for joining us today. And we will then conduct a poll, as mentioned above, using your cell phones and the cloud, but not leaving Earth any further than GSO. I will provide instructions at the right time, but let me just say this. You take out your phone, you get on a browser, you open up the PSW Science webpage, you'll see a banner at the top, you click on the banner, it will bring up the voting form, you pick your vote, and you're finished. And when we've had sufficient time for everybody to figure out how to do that, the results will be displayed on the screen. Alan and Ron will be in the back of the room, so you won't be able to see their expressions when they see how the vote turned out. But I will. With that, it's my pleasure to introduce the speakers, Ron Ekers and Alan Stern. Ron is a fellow of Australia's Commonwealth Scientific and Industrial Research Organization, fondly known as CSIRO, and an adjunct professor at Curtin University in Perth. He was president of the International Astronomical Union, known as the IAU, from 2003 to 2006. Previously, he was director of the Australia Telescope National Facility and of the U.S. Very Large Array. Recently, he's been instrumentally involved in the proposal to build the Square Kilometre Array. Ron has pursued a broad range of research interests, including studies of galactic nuclei, ultra-high energy particle physics, and fast radio bursts. And he specialized in innovative applications of radio astronomical techniques to astrophysical problems. Among many honors, Ron received Australia's Centenary Medal, the Flinders Medal from the Australian Academy of Science, and the Grote-Reber Medal. He is a Fellow of the Royal Society, the Australian Academy of Science, the Royal Dutch Academy of Science, and, most importantly, the U.S. National Academy of Sciences. It's a high honor. And he is also a former member of the American Philosophical Society and an officer of the Order of Australia, and as of tonight, a member of the Philosophical Society of Washington. Ron earned a Bachelor of Science in Physics at the University of Adelaide and a PhD in Astronomy at the Australian National University. Alan is a planetary scientist, space program executive, and author. He leads NASA's New Horizons mission to the Pluto system and the Kuiper Belt. He is also the Associate Vice President and Special Assistant to the President at the Southwest Research Institute, Chief Scientist of the Florida Space Institute, a member of the U.S. National Space Board, and he leads a consulting firm. Previously, he served as Chief of NASA's Space Science Missions. Alan's research focuses on studies of the outer planets, the Kuiper Belt, and the Oort cloud, comets, and exoplanets. He has also worked on spacecraft rendezvous theory, galactic astrophysics, and studies of tenuous satellite atmospheres. He is an author on many technical papers and popular articles, and the author of 2 books, The U.S. Space Program After Challenger, and Pluto and Charon, Ice Worlds, and the Ragged Edge of the Solar System, with a 3rd one. Published or on the way? Already published. So I'm remiss in not having the title of that, although I think I have a copy down there. Sorry. Anyway, Alan is a fellow of the AAAS and the Royal Astronomical Society. Among many other honors, he received NASA's Van Braun Award, Aerospace Achievement Award, the Smithsonian Magazine's American Ingenuity Award, the American Astronautical Society's Sagan Memorial Award, and he has twice been named to the Time 100. Alan earned BS degrees at the University of Texas and MS and PhD degrees in aerospace engineering and atmospheric sciences at the University of Colorado. Tonight's meeting of the Society is given over to debate on the correct or best definition of the word planet and on the method of establishing its formal institution by the planetary science and astronomy community. One definition is the IAU definition adopted in 2006. A planet in the solar system is a celestial body that is in orbit around the sun, has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium, nearly round shape, and has cleared the neighborhood around its orbit. Ron will present the case for this definition. The other is the Geophysical Planet Definition, or GPD, proposed by Alan and Kirby Runyon and others. Kirby is a PSW member here with us tonight. According to that definition, a planet is a substellar mass body that has never undergone nuclear fusion and that has sufficient self-gravitation to assume a spheroidal shape adequately described by a triaxial ellipsoid, regardless of its orbital parameters. Alan will present the case for the GDP definition. The definitions differ in a number of important ways. Whether orbital parameters are important, that is, does the body revolve around the sun? And whether the body has cleared its orbit, i.e., is it large or massive enough to sweep its orbit clear of other objects? The IAU definition relates to dynamical properties, orbital and clearing parameters. The GDP definition relates exclusively to the extrinsic properties of the object, except for the reference to fusion. As most likely you all know, the IAU definition denotes 8 bodies as planets in our solar system and classifies Pluto as a dwarf planet or a Plutoid, although that doesn't quite fall out of the definition itself. The GDP definition includes at least 110 objects in the solar system as planets. The merits of these definitions and the best way to decide which should be the official IAU definition are the subjects of tonight's debate. With that, let me invite Ron to the stage to make the opening 20-minute presentation. Ron.
So thank you, Larry, for that rather over-the-top introduction. And thank, of course, the Philosophical Society of Washington for giving me the chance to explain a little bit about what this organization, the IAU, is and how it got involved in the definition of a planet. You've even given me the opportunity for adding another post-nominal, so thank you for that. On the screen, yes, ready to go. What I would like to start off is to take this opportunity of telling you what the International Astronomical Union is. Sometimes from faraway places like the United States, these international organizations may seem rather distant. And it's pretty important to the story, in fact, to go through this. So, after the end of the First World War, a thing called the International Research Council was formed. It was formed by the Allies, and it was an outcome of the war effort. We would like to think that these international bodies are born out of international idealism, but this one, in fact, was born out of conflict. So it's just a statement of fact. And that was for many years a serious issue because the Central Powers, so Germany and the other powers, could not even be members of this organization. So it's a little bit of history which is not that well known. But in 1919, when it was formed, one of the first things it did was said, we need international bodies to coordinate efforts in different branches of science. And so in 1919, not got as much history as the PSW, the IAU and a number of other disciplines formed their unions. And I'll give you an example of the kind of reason they were formed. So in the case of astronomy, it was to coordinate time. And you will realize that's very practical, that all the countries in the world run their clocks on the same time, and there has to be a process for doing this. And I'll even use this to illustrate a point I will make many times. Coordinating all the clocks around the world is not itself science. But if we don't do that, it makes the pursuit of science very difficult. So these are practical functions which these international unions have to do. Its other initial job was to issue telegrams, that is, if a star explodes, to send a message out to astronomers so that they can all get together and do signals. IAU was also given the job of naming things. Up to that point, one of the big efforts had been to name the craters on the moon, as better observations were finding more of them. And an international working group had been set up previously that was taken over by the IAU. So you see the history of IAU being involved in naming things in the solar system goes back quite a long way. I will mention another job they had. As you probably know, stars are named traditionally after the constellation that the star is in. Again, if you want to agree between different places in the world that you're looking at the same star and you use its name, you want to have a convention that is consistent around the whole world. And one of the other jobs was to define where the constellations end, so you know which star is in which constellation. This is another example of a very practical requirement so that scientists can communicate, but is not in itself a science. Which is the first comment I make there. So agreeing on how to name things is an essential part of doing science so that we can communicate with each other. And in the case of astronomy, since all of us in the world see the same sky, it is even more important that we agree on what we call things so we can communicate. An example from a very different field of the importance of naming things is 1753, when Linnaeus proposed, instead of all the different animals and biological specimens having different names in every country, they introduced genus plus specific names, e.g. Homo sapiens, and to remind you, of course, 250 years later, this is still used. So my point here is that the process of setting up ways of naming things is a really important part of science. As I already mentioned, the International Astronomical Union was already involved in naming things in the solar system and has many different working groups to do that. And my second point is repetitive. Let me go on. Generally, this naming goes on without anybody really even realizing that this happens and how much work has to go into it. But occasionally, you may have to name something and make a decision which does affect people more generally. And the obvious question, which is the question for the debate tonight, where the whole public and people interested in science or not were very much engaged in the issue of whether Pluto is a planet or not. So in this case, the IAU is not making a decision which is, in the backfilled rooms, but something that affects everybody. Now, these international organizations, they do not make international law. when it's decided to do something, no law is passed to say that everybody has to do it. Instead, these are agreements on conventions. And the way to make a decision on an agreement to use a convention is to have a vote. It is a very standard process which all democracies use, and it's the process which is used by the IAU. Again, I'm stressing this point over and over, this is not a vote about science. The vote at the IAU was about an agreement on how you name things, and that is an important difference. This will work up to the real issue, but I thought I would just run through the discovery of one of the planets, Neptune, because it's an interesting story and it'll fit into my theme. The planet Uranus had been found by Herschel already, and people were plotting its orbit. That's how smoothly it moves across the sky. And they discovered that it was having small perturbations in its orbit. Frenchman Leverrier predicted that these perturbations could be caused by a large mass outside of the orbit of Uranus. And in 1946, at the very location that he had calculated, an observation was done and the planet Neptune was discovered. So this is a really nice example of how science really does work. You make a model of gravity, the motion of objects in the solar system. You can predict that something new is going to be there, and in the case of Neptune, it was discovered. In the 1930s, partly due to errors in the data, it was thought that the orbit of Neptune also had some wobbles in its motion. And based on that, there was a prediction that there would be another planet outside of Neptune. Tombaugh, then using incredibly new equipment, very good for searching for planets, looked and he found the small moving object, which was Pluto. However, we later found out that this was discovered not because of any scientific prediction, but because of the power of his technology. And he had found, in fact, what was the first of a new class of objects, which is what I will get to. And in fact, we now know that Pluto has no influence whatever on the orbit of Neptune. Now, in 2005, the situation came to the attention of the IAU, and this was partly because many more objects were being found which were like Pluto. The map I'm showing you here shows the planets. They're labeled by letters: Saturn, Jupiter, Uranus, Neptune. And all of these spots outside of the planets are called trans-Neptunian objects outside of the orbit of Neptune. They have a range of sizes, the larger ones like Pluto and many smaller ones. And as you can see, there are hundreds or thousands of these objects. One of them, at the time, called 2003 UB313, was found by Mike Brown at Caltech, and he was able to show that it was almost certainly larger than Pluto. So, is it going to be named? Now, IAU agrees on the names that are given to new objects that are found in the sky. However, there was no definition of whether it was a planet or not, and that meant the process for naming it could not be continued, because you had to first make a decision of whether it was going to be called a planet, in which case it's named after a major god, or not a planet, and it's not. All of this seems ridiculous, but this is part of the conventions agreed on for naming things. So how does the IAU get the answer to this? Well, the IAU goes to its experts who do science, and they ask the Planetary Systems Division of IAU to make a recommendation. Is Pluto going to be called a planet or not? And what we got back, and we actually did this twice, was the committee of experts said, well, we agree on the science. There's a new class of objects, the trans-Neptunians, the Kuiper Belt objects. Pluto is one of them. We don't have any disagreement about that. However, our committee cannot agree on whether we call it a planet or not. And they came back to the IAU saying, well, we have a gridlock. Here are three possibilities, and we can't decide between them. One says, well, Pluto, we want to be a planet. That's what people know and understand. So we'll set that as the minimum size, and anything bigger than Pluto is also a planet. The other suggestion was, but if we include the dynamics of the solar system, then we have a way of separating the major planets, which gravitationally dominate the orbits of the smaller objects, and Pluto is much too small to be dominating the orbits of anything else. So if we include that in the definition, then Pluto wouldn't be a planet. And the third thing, which was, I think everybody actually did agree to, that planets have to be round. They're not rocky lumps of rock called asteroids. So that's the hydrostatic equilibrium, and that you find also in Allen's GPD definition, so that they have to be round. Then the question is, well, should we just take all the round objects and call all those planets? So, okay, IAU now has a problem. It's its expert committee, and it can't give an answer. The reason it can't give the answer is because deciding between 1, 2, and 3 is not doing science. This is deciding how you name things. And so what we did was we formed a very different kind of a committee. We called it the Planet Definition Committee. Here they are here, and there's their names. And we made sure we did a few things. First of all, this is not a committee of planetary scientists. We came to the conclusion that maybe the planetary scientists are not in the best position to decide what's a planet or not, surprisingly, and I'm sure Alan will take me on this point. But we included historians, science writers, educators, and we also made sure that we were getting the opinions from many countries in the world, not just a group in North America. So that committee came back with some suggestions. Now, we're going to have these decisions are only made at the IAU every 3 years, and the next General Assembly, as it was called, was in Prague. And we on the executive decided that we would set everything in process to have a resolution put forward, and incidentally, we are fortunate enough to let me go on. So this was all set in place. Now, here is one decision where I think you can very much question what the IAU did. We decided not to discuss this in public before the meeting in Prague. That was partly because we were requested by some members of the committee because they did not want to be under pressure from the press, from many people, to affect their decision. So we agreed that we would keep this quiet, and it was not announced. That I am willing to accept may have been the wrong decision. It's rather hard to tell what would have happened. Certainly there would have been a lot of pressure. So we meet in Prague in the 2 weeks of 14 to 25 August 2006. Now the process in Prague goes as follows. Prague has got all kinds of astronomers, a small number of planetary scientists, but professional astronomers. These are people whose career is astronomy. They understand astronomy. They don't study planets, most of them. A few do, but mostly don't. So the process is that the experts present these different ideas to this group of people. And there was a completely open discussion. We also invited the press to that discussion, so it got lots of coverage. And the various options were debated. In this process, the initial version of the resolution was changed as a result of the feedback that we got. And that resulted in what was put up earlier as the resolution of the IAU. And it included the fact that the planet has enough gravitational influence to influence everything else in its orbit. Now, that was included, and I will say why that was included, because when we have the debate, we have people like Alan who study the geophysics of planets. They cared very much about the constitution of a planet. Is it round enough? What kind of an object is it? But we have the planetary dynamicists. These are the people who care about the orbits and the way gravitationally they affect each other. They care about how solar systems formed. And one remark I can remember quite clearly was, if you don't include the clearing of the orbit in the definition, you have insulted half of the planetary science community. And it was quite clear that, that their arguments had a lot of influence on the independent group of astronomers who were listening. So the concept of a dwarf planet is then arises. That's if it's round, but it hasn't been able to dominate its neighborhood. And I see I need to go pretty fast. And so this resolution was passed. I will just touch on the fact that there were 424 professional astronomers in Prague who voted. That's a very small fraction of the membership. But in a democracy, when you vote to make a decision, which in a sense is arbitrary, it could be named this, it could be named that, this is actually a large enough sample to get an adequate sampling. So I'm not worried about that. There's the actual vote being taken in Prague. We also put up a compromise resolution, Resolution 5B. And here the idea was dwarf planets are also planets. And that IAU thought might be a good way to remove some of the hostility between the two camps. However, that vote failed quite significantly. And I think there's an interesting message in that. So that's why, from the IAU's perspective, the decision on the status of Pluto was decided at 1534 Central European Standard Time, 24th of August 2006. So under that definition, it's no longer a planet. Now, the the definition which Alan will propose includes exoplanets. Now, this is not something that IAU forgot to do. The reason why IAU is very specific, we have defined a planet in our solar system. It was absolutely clear that that's what we wanted to do. And we did not want a complication of including exoplanets. They were just being discovered. There was no questions being asked of IAU related to the naming of the planets. And so we did not. And exoplanets is for a future debate, which Alan, of course, will be part of. And that's why the no fusion comment comes up. But that is not what we decided at the debate on the definition of a planet in our solar system. There is a process in place. Now, just before I finish, I wanted to show you this beautiful example of why including dynamics really matters. Here's the current status of some of the Kuiper belt objects, which have very large elliptical orbits. And they have a strange distribution on the sky. It's not at random angles, as you might expect. And that is the reason why people are proposing a Planet 9, another planet, not Pluto, but something big enough to be perturbing the gravity of its neighbors. And so, including dynamics in the definition of a planet, I think fits very well, and maybe the way in which an actual new planet 9 is found. And that's the dwarf planets, and I'll skip all that. I will make one comment about Alan's brilliant mission, New Horizons mission. I've added this little point to it, which was the point at which the IAU declared Pluto to be a dwarf planet. But I put it to you, Was Alan going out there to find just another planet? Isn't it more exciting that he was making the first observations of a completely new kind of object, a dwarf planet? And I'll skip the epilogue. Okay.
Well, thank you, Ron. I think you went over a little bit, so we'll afford the same amount of overage time for you soccer fans to Alan.
That was a nice job.
Alan?
And thank you for the compliment.
Now, what did you do here?
Are we ready?
Hopefully.
Make sure you don't bring
You
up the
want your
backup.
first one or your second
The first
one?
one, the non-backup.
Okay.
Nope. There
Your
you go.
speed readers.
Shall we begin?
Are you on?
Am I live? Can you hear me? Okay.
Yeah, you look good.
Okay. Well, let me join with Ron in saying thank you to the Philosophical Society of Washington for hosting this debate, and thank you, Larry, who put in an amazing amount of time. I also want to say thank you to Ron for accepting the challenge of coming to Washington and doing this debate. Be happy to debate you anywhere. Congratulations on your just announced appointment to the National Academy. That's just fantastic. Okay. Oh, Lord, where do I begin? You know, well, hopefully it wouldn't be you, Ron, but for anybody in the audience, let me just say something about the value of expertise. If, God forbid, somebody here were to be diagnosed with a neurological problem, I would hope that you would go to a neurologist and not a podiatrist or some other form of doctor, because expertise does matter. So I'm going to talk to you about the geophysical definition for planets, and I'm going to have 5 things to say, and I'll walk you through those 5 things. But I want to start with the science. I want to talk to you about some of the revolutions in planetary science in my lifetime, in my career. I think that there have been 3 really fundamental game changers. The first was the discovery by NASA spacecraft and by ground-based observatories that oceans are common in our solar system. We didn't know that at the beginning of the space age, and now that we know that they're nearly ubiquitous. The second big game changer was the discovery of the Kuiper Belt, the 3rd zone of our solar system that so transformed our view that what we used to call the outer planets, the giant planet region, we now call the middle zone of our solar system. And the Kuiper Belt is the largest structure in our planetary system and has transformed our understanding of planetary origins in ways that I won't go into tonight, but that are absolutely fundamental. And the third big discovery was the discovery of dwarf planets. You know, Pluto was discovered in 1930. Astronomers and planetary scientists looked for decades. It took 6 decades for the technology to allow the very next such detection in 1992. And by the time we got into the beginning of the 21st century, we had discovered many dwarf planets, a 3rd class of planet in our solar system. This is absolutely fundamental, and in fact, even more so, the fact that the dwarf planets outnumber both the giant planets and the terrestrial planets combined. This is such a fundamental discovery that our National Academy of Sciences, to which Ron now is a member, ranked in the decadal survey the exploration of Pluto, the first dwarf planet of the Kuiper Belt, and the further exploration of the Kuiper Belt by spacecraft as its #1 funding priority of the 2000s decade. And that became the New Horizons mission that you know about. And this is Pluto. There's a large view of the planet taken by New Horizons on approach, and then a view looking back, seeing its beautiful blue atmosphere. Look at this place. What would you call this on an episode of Star Trek? The moment that the Enterprise shows up and the viewfinder comes on, you would say they are orbiting a planet. This is a world with an atmosphere made of the same stuff that we're breathing. Almost certainly a liquid water ocean on the inside, with mountain ranges and tectonics, with a complicated activity that's going on inside it today and on its surface, with glaciers and avalanches and all of the hallmarks of planetary processes that we see. And this is only the first of the dwarf planets that will ultimately be explored by NASA and perhaps other nations. Now, the second thing that I want to talk to you about is not the importance of the discovery of the Kuiper Belt and the population of dwarf planets that has shook my field. I want to talk about the IAU planet definition. It's already been up on the screen twice, so I don't have to go through it in detail. Basically, it's limited to objects in orbit around the sun, not planets around other stars. I think that's a mistake. We should have one definition for all planets. Secondly, has sufficient mass so that it assumes hydrostatic equilibrium. Close. Yep, we all know that planets are big round things, so that gets towards the right answer. But then there's an extraneous third criteria, that it has cleared the neighborhood around its orbit. And that's where planetary scientists part ways, generally, with the astronomers. Again, this definition that I just read was created primarily by non-experts who study stars and galaxies and black holes and cosmology, and I am quite certain that if a group of planetary scientists had a meeting and tried to classify galaxies or black holes, we would botch it. Because although we're in a neighboring field, we really aren't the experts. And most members of the IAU are not planetary scientists, and moreover, most planetary scientists in the world are not in the IAU because they don't consider themselves astronomers. They're studying geophysics and geochemistry and the origin of planetary bodies, which is separate from the study of stars and galaxies. And by the way, Ron, one thing that you said, the only thing I think that you said that was blatantly incorrect is that about half the members of the IAU who are planetary scientists would have been upset had you gone a different way. In fact, only the dynamicists, who themselves are a small fraction of the planetary scientists in the IAU. Now, the other thing that's odd about this is that we don't usually in science engineer definitions to achieve a specific result. In this case, the IAU planet definition, or the IPD, was engineered to specifically limit the number of planets. And in press stories following the IAU vote in 2006, IAU members, perhaps including Ron, often justified the definition as helping to save school children from memorizing too many planet names. We'll talk about that. You know, I just think, maybe it's just me, but isn't it a little strange that astronomers became afraid of astronomically large numbers of objects? Nowhere in astronomy are there limits to the numbers of stars or galaxies or asteroids or moons or anything else in the universe. In fact, astronomers, cosmologists think that there may be a multiverse. There's not even a single universe. And they're happy with all of that. Defining planets so as to limit their numbers is a complete anomaly in astronomy. In fact, I believe in science as a whole. In fact, limiting the numbers of things in science for convenience is kind of weird. Now, many of you know the name Mike Brown, and Ron mentioned it. He discovered a number of the dwarf planets in our solar system. He likes the IAU definition. I was once debating him on the Ira Flato's Science Friday show. And Mike said, look, we just can't have school children remembering the names of 50 planets. And Flato turned to me on the radio and he said, Alan, what do you think of that? And I said, well, I guess we're going back to 8 states. Do we limit the number of rivers simply so we can remember the names of them? Or mountains? Or elements in the periodic table? Of course we don't. Let's take a look at that periodic table. Every kid learns about that. There's well north of 100 elements in the periodic table. No one is worried about memorizing their names. Memorizing the names of all the planets is a 20th century concept, driven only by the fact that we only knew of a few. Just as I live in Boulder, Colorado, and you can only see 4 mountains to the west. And if you were an Arapaho Indian there in the 19th century, you might think there are only 4 mountains in the world until you scaled to the top and saw the vast sea of the Rockies and realized that the mountains are too numerous to name them all. Let's look at the IAU's periodic table with 8 elements. How about that? Fortunately, oxygen just barely qualifies, the 8th element. Numbering things for convenience in science is actually anti-scientific. And let's talk about some of the serious scientific issues with the definition that Ron favors. What is a cleared zone? This is an actual depiction of our solar system, the orbits of planets in it. This is the inner solar system primarily, and all those dots you see are actual real, discovered objects, near-Earth objects, and various asteroid and comet populations. What does it mean to clear the orbits of the planets when the orbits are not cleared? You hear all the time, such and such an asteroid just passed by the Earth. We took a near miss. That's because the Earth isn't clearing its orbit. The orbit is not clear. In fact, there's no place among the planets where there is a fully cleared zone. So by literal interpretation of the IAU's definition, no solar system planets qualify because none of the zones are cleared. But even more, the IPD, the IAU planet definition, is not based on an object's own attributes. It's also based on its location and its surroundings. It's what it's around, which is different from, in geology, we don't care if a mountain is out by itself or in a mountain range. In biology, it doesn't matter if the species is in a herd or isolated. In fact, when you work it out, the IAU planet definition inherently and strongly biases against distant planets. Because as you go further and further out, the zones get larger and the orbital speeds get slower, and those two things combine to make it harder and harder as you move outward to clear those zones. So you acquire larger and larger mass planets when you get farther out. Let me illustrate that point a little bit further. Here's a nice plot, and don't worry that I got this off Twitter. The actual plot is from a paper about planet definition by an IAU member who's a dynamicist and tried to quantify how the IAU planet definition works. And you'll notice those lines that are sloping up to the right. That's how big an object has to be as a function of its distance from the sun in order to qualify. If you go all the way out to the Oort cloud, even Jupiter would not qualify as a planet by the IAU definition. The Earth wouldn't qualify as a planet if you took it out about 100 astronomical units. In fact, imagine a solar system that consisted only of Earths in the orbits of the 9 planets that you grew up knowing, and then more Earths further out. Identical objects. Some would classify as planets, and others would not. Identical objects classifying differently just breeds confusion. So there's a better way. It's called the Geophysical Planet Definition, created by planetary scientists who actually do this stuff for a living. And here it is in quick paraphrase. It's a celestial body that has sufficient mass so that it can assume a hydrostatic equilibrium shape, but with insufficient mass to undergo nuclear fusion in its interior. Short, sweet, and simple. It's about what the object is and not where it is or what's next to it. And it's got some great advantages. First of all, it's only based on the object's attributes. So by studying the object, you can determine if it's a planet or not. You don't have to know about the entirety of the rest of the solar system. It's parallel to most other categorizations of objects in the universe. The definition of stars, for example, is based upon their attributes, not what they're next to, whether they're in a galaxy or not, or a cluster or not. It's agnostic to the number of planets. Large or small, give or take, in any given planetary system, it is what it is. It's about what objects qualify. And it applies to all planetary systems, not just our own, which I think is very important because the IAU planet definition for extrasolar planets is very different from the definition in our own solar system. I mean, who ordered that? We're going to have planets that qualify one way in every stellar system except our own, and then in our system we're going to use a different criteria? Science is ultimately a reductionist pursuit, so we should try to have a grand unification, including a unification of terminology. Here are a couple of other advantages of the geophysical planet definition. It doesn't depend upon the locational environment, so it embraces the diversity of planetary types and orbits, and it's intuitive to use. You could pretty much do it just by looking on the viewfinder of the Starship Enterprise when it shows up. You know as a member of the audience if you're looking at an asteroid or a comet or a planet or a Klingon spaceship or whatever this week's episode is about. So let's talk about this one more way. Both of those objects are dogs, aren't they? They're very different in size. It's not about whether the Chihuahua is in a big herd of Chihuahuas or in any group of dogs. It's not about whether the big guy is in a group or not. Typically in science, normally in science, we classify species, geological formations, and other objects in space by their own attributes, with nothing engineered to limit the number. I think that the IAU made a tragic mistake, and I'm going to stop right there. Looks like I've got some spare time that I can give back, and I'd like to hear Ron's rebuttal. Thank you.
Okay, Ron. Do you want me to put your slides back up?
Maybe just the last one. Not that one, the one before it, I might.
Oops, sorry. That one?
Yeah, just leave that there for a minute. Okay, well, of course, thank you, Alan, for, as we would expect, enlightening people about the wonders of our solar system and all of the fascinating things. In particular, Alan pointed out, we have discovered this amazing Kuiper belt objects, fascinating new part of the solar system. But in science, you do get advantage by classifying things. Pluto and the rest of the Kuiper belt objects are hugely different from the things that we traditionally call planets. And so he showed two dogs different by a factor of a few, maybe 10 even in mass. We're talking about hundreds or thousands. These are very different objects. All right, but let me just go through the list here. Value of expertise. Yes, you bet I would want an expert medical practitioner to cure a disease, but I would not ask a medical practitioner to name the disease. I would rather have somebody who knew something about linguistics and good ways for communicating. And that's where we're getting confused here. We're confusing the process of naming and the process of doing science. Absolutely agree, the images of Pluto are wonderful, and it has many properties which we've come to associate with planets. And I imagine the hundreds, maybe even thousands, I don't know what you think the limit will be, on objects in the Kuiper belt. There'll be many of them which are as fascinating. You somehow got the idea that IAU started with some idea that there must only be a small number of planets, and maybe somebody said that as a joke so children could memorize them. But again, I'm saying it is very different when you're adding hundreds of objects, which are quite different, to a class of objects which we understand to be planets very well. So I don't really buy that. It is the case that it would be very good if we could have a definition of exoplanets which also worked. But of course, and correct me if I'm wrong, Alan, I don't think we have we will ever be able to detect things the size of Pluto in exoplanets. So it's not really an issue. We're not going to get confused with the exoplanets. And also, there are thousands of exoplanets. They will be defined as planets when the various committees report on the best way of doing it. And there will be nobody saying, oh, we can only have 8, the exoplanets aren't planets. So you can dismiss that from your mind. That's a kind of a nonsense story. There are many galaxies, of course, and there are many planets. There's no doubt about that. But in our solar system, we only know of the 8. Clearing the zone needs a little bit more careful attention. When we make a definition of the planet in a body like the IAU, you also have to think about keeping the terminology simple enough so that people with a modest amount of scientific background can understand what it means. Because of that, we weren't able to put a more sophisticated definition of clearing the orbit. Clearing the orbit was not made up by people who work on AGNs. It was made up by the dynamicist planetary community as a simple description of a process where the giant planets throw things out completely. However, satellites of planets, well, they're in orbits around the planets. They're not thrown out. We didn't mean to imply that they had to be thrown out as well, or else you'd be saying the Earth isn't a planet because it's got a moon. These objects, which Alan showed you, are in resonant orbits with the big planets. So the planet goes round once. These are completely gravitationally locked to it. They have no free will. They have no independence. And that's the real intention of clearing the orbit. It doesn't mean there are no objects there. What it does mean that an asteroid passing the Earth is going to have no gravitational impact on it. So I think the dynamicists do understand that. And in fact, Jean-Luc Margot in 2015 has published a theoretical paper showing that this definition is quite sound. The other reason why, even though written in simple words, the difference is huge. It's not a small difference, as Alan implies. The difference between the 8 planets and everything else is not a tiny difference. It's a huge difference. The Kuiper belt objects have got no gravitational influence on anything else. So it's a big difference. And the last of the arguments, which is really an interesting one, should surroundings matter? Should the name of something change when it's in a different location? Well, I think actually in science we have other examples where that's exactly what happens. So if you have a mountain and it happens to be in the sea, or after the sea level has risen, we don't call it a mountain, we call it an island. We don't get confused about that. It's the same lump of rock. It's an island in one case, a mountain in another. So I don't see any difficulty in the location of the object mattering. And in fact, you sometimes see in science that the attempt to do this kind of unification has resulted in bad science. We have a science of epigenetics. It says that the genetic code by itself does not tell you how your body's working. What matters is the surrounding that it's in. It makes a huge difference. So yes, nice idea, but too simplistic, and so I don't buy that argument. And I guess, what have I got? Oh, I haven't used enough time. I had a few things here in the epilogue which I missed because I went a bit over time in my talk, and I just might mention some of those. The debate in the IAU, which was done very publicly, had a dramatic impact on the popular science. Not as much as New Horizons, I'll perhaps grant, but nevertheless, a huge amount of attention. And a lot of people learn not just about planets, but the process of doing science. And the point is, as you get more information, if you're doing good science, you will make changes and corrections. We genuinely thought that Pluto was comparable to the size of the Earth back when it was first discovered. And in fact, it's thousands of times smaller. So we make changes. We are not stuck in some tradition that says, well, because we once thought it was a planet, it always has to be a planet. And then even worse, to say it's just the size when you call things planets is not good science. The other comment I already made, perhaps in passing, is when you're voting on things like names, who are the right people to be voting? Should it be the planetary scientists, or should you take intelligent people, let them listen to the arguments, and then vote? So when the Congress makes legislation, the people making this legislation have been voted for, but they are not necessarily experts in the topic that they're making legislation for. That is the way the system of consensus works. And as I said many times, naming things is not the same as doing the science. Is there any other? There's a few other things that you might find. This is to make this a little bit more interesting. We, of course, got quite a bit of feedback. One of the ones I thought was interesting, so somebody might want to react on that. The astrologers, by the way, were very upset because they said, well, we're the experts in this field, and you didn't even put any of us on your committee. So, and I mentioned the orbit. 2006, Pluto became got the Word of the Year award from the U.S. Society of forgotten the name of it, looking at meaning of words. The other thing that struck me, I went to visit one of the solar system exhibitions, which you get all over the world. And there was a little ceremony where they took Pluto off its pedestal, put it in a little coffin, and took it back to the center. But then they did something which was exactly spot on. They said, this is the nature of science. Things change. Things aren't fixed. As we get better observations, we can change our views on things. And so I thought, that is really conveying a scientific message, and an important one. So that's the reason why IAU is the reasons behind the decision it made. And I would suggest to you that we leave it as it is. And if you were to attempt to get yet another definition of a planet, then I don't think that is the best way to go.
Thanks, Ron. Okay, Alan.
You want to bring up my slides?
Yeah.
Same set. This is the same.
Yeah, where you want to be.
No, yeah, we're going to go back here.
You'll get
All right. Well, I think this is why you don't want non-experts. Let me just comment on a few things that Ron just said. He said that Pluto-sized exoplanets don't exist. I'm very surprised you would say that, because in fact, the very first exoplanets ever discovered around pulsars with radio science techniques in which you are an expert included objects the size of asteroids, thousands of times smaller than Pluto. Secondly, you said that Pluto is thousands of times smaller than the Earth. It is, in fact, a diameter ratio of 7 to 1. That is a misstatement. The dwarf planets are not that much smaller. 7 cubed in mass. You said the size is thousands of times smaller, and you're giving the impression to some people in the lay audience, perhaps, that Pluto is the size of Washington, D.C. It is not. It is the size, it has the surface area of the United States. All right, but this isn't about Pluto, and I want to stress that this is for planetary scientists about proper categorization of the central objects for which our field is known, planetary objects. And we need to understand what objects are and aren't in the bin of being planets. And so I want to also say that the Margot paper, which you referred to, is absurd in its conclusions. This graph is in fact from Margot's paper, and it shows that different objects classify differently just because they're in a different place, even though they are identical. As if you might qualify differently as a Homo sapien, whether you were in this crowd or by yourself, for example. And I also want to refute one other statement that Ron said. He said just a few minutes ago that the IAU acted in the open. But I will remind you that in his first presentation, he said that we agreed to keep the secret. And then he said that the dynamics community is who dreamed up this silly clearing criteria. In fact, it was not the dynamics community. Most planetary dynamicists, and in fact, most astronomical dynamicists were not even in Prague. It was Brian Marsden, who is a dynamicist, and a handful of his pals that more or less fomented a little revolution in Prague. Now let me go to my charts. So let's pick up where we left off. Ron said that things that are very different in size shouldn't be classified similarly. How about stars? Neutron stars are the size of the Earth, and they are stars. Look at the size of Antares and Betelgeuse compared to the sun, which is the little white dot. By this standard, if it was just a matter of size, the sun, which is classified by astronomers as a dwarf star, look it up, would not be a star. It's not about size, it's about attributes. Planets also span a wide range of sizes and masses. So what? That's the data. These are the small bodies of our solar system, and this is what a typical Kuiper belt object is like these asteroids. They don't look anything like planets, and you would never misrecognize one if you saw one on the Starship Enterprise or in a textbook or in an article. I'm not going to go through this long list of the attributes that small planets have in common with their larger cousins, but they are completely aligned, except in size, the same way that the two dogs are both in the same species because they share all the common DNA and attributes of the canine species, and it's not about just their size. Small planets have a lot more in common with the other planets than they do with small bodies. Here's Pluto, again, surface area about the United States, and here are all these small bodies, which are not at all in the same category, and yet the IAU definition confuses by mixing these two types of objects together. Now, less than a week after a few hundred people had a split vote on short notice in Prague at the IAU meeting of 2006, 300 planetary scientists, in less than a week, signed the following statement. We as planetary scientists and planetary astronomers, that means, do not agree with the IAU's definition, nor will we use it. A better definition is needed. More scientists signed on to that in the space of a few days after the Prague meeting, rejecting it as a dysfunctional categorization, then voted on either side in Prague. And if you think that was 2006 and this is 2019, let me tell you about Phil Metzger. Phil Metzger is a professor of planetary science at the Florida Space Institute and a very well-known planetary scientist. He's been in the field for more than 2 decades. Metzger has done a literature search and has found 0 papers in the planetary science literature since 2006 that use the IAU definition, except for papers like Metzger's, papers on the dynamics that actually talk about the IAU definition, but no paper is using that definition because it's operationally useless to planetary scientists. Let me just play you something from a meeting just a few years ago, a Pluto meeting.
And all the small planets that are there were not even
They're talking about Pluto.
with the exception of Pluto.
I'm really delighted to see so many people who are interested in the 9th planet.
You've got this little dinky planet.
So this is the entire surface of the planet.
There's this angle, the resonant angle, phi 32, which is 3 times the longitude of Pluto, which is basically the sum of the angles which locate, in the low inclination case, how far around the orbit the planet is from a reference point.
If you let the planet become more and more oblate, you get central flashes.
You know, it's a shame.
Well, that goes on. I played about a quarter of it. And my point is that it's not just that Metzger couldn't find planetary science research papers that respect the IAU definition. Planetary scientists are voting with their feet when they're talking about dwarf planets and Pluto. They're using the word planet reflexively because they don't know what else to call these objects. The other side of the coin that Metzger found is that hundreds of planetary science research papers use the GPD definition. He found none that use the IAU definition. So the experts in the field, numbering in the thousands ultimately, who are not members of the IAU, could be perfectly happy if the IAU wants to have its planet definition that confuses the whole field of planetary science, but they're not buying it, they're not using it, and the data is in the literature. You don't have to take my word for it because Metzger is now writing this up. I thought I'd do one other thing, but I'm not sure if I can get my other PowerPoint up and running. Maybe I can get a little help from Larry. Which one is the backup? How do I click on that? Sure. Is that the backup?
That is the backup.
I thought I'd play one more, I thought I'd play one more audio for you from 2016 on Star Talk Radio, Neil Tyson. We just clipped out one little bit, but I want you to hear it because the sea is changing. Whoops. Whoops, can't play it. There it is. There's the click in the right place.
If dwarf planet is a category of planet, I have no problem with that.
Uh-oh.
If dwarf planet is a category of planet, I have no problem with that.
So Neil's folded too.
If dwarf planet is a category of planet, I have no problem with that. If dwarf planet is a category of planet, I have no problem with that.
All right.
If dwarf planet is...
Well, I think I've made my main points. The IAU definition really botched the job. It miscategorizes objects by confusing where they are with what they are, and planetary scientists simply don't use it, the real experts in the field. And again, it's fine if the astronomers want to have one definition, and the planetary scientists have another. I guess that's okay, but really the press and the textbook writers should respect both definitions and give them equal space in textbooks. And I think maybe I'll stop with that and we can have our Q&A period. Thank you very much. You want me to come down?
You're going to be without your... I got to put this up.
Can I occasionally call for slides?
I'd rather you did.
Only if it answers a specific point.
I'd rather you did. It's complicated.
Okay.
Did I get your definition wrong? 'Cause
You did.
showed- I'm sorry.
3.
Looks like we're ready for a little Q&A. So we do have a procedure here. And the procedure has to do with the runners that have microphones. The microphones have foam covering. The covering is colored. Keep your hands up long enough for somebody to bring you a mic. When you get the mic, I will call on people by the color of the
Ron,
microphone.
you want water?
When I do, stand up, tell us your name, tell us if you're a member, and ask a question. Reserve dialogue and monologue for the social hour. So we'll start with Jim Green here.
Yeah, Jim Green.
Hold it up to your mouth.
Okay. Jim Green. Yeah. Jim Green, and I'm a member. My understanding then, from the IAU definition, that the newly discovered set of objects that used to orbit stars, that due to gravitational resonances that have been thrown out of the system of those stars that we used to call planets, that are now orbiting the galactic center, would not be called planets because they don't orbit the sun. They haven't cleared their orbit. They're exoplanets that have been ejected out of the system. So based on that definition, we'd have to rename them something else. They used to be planets, but they're no longer planets.
Okay, so the IAU only provided names for objects in our solar system. They did not address the exoplanets, and in particular, there are various categories of exoplanets, one which you just mentioned. These are objects which are like planets which have been ejected from solar systems. We did not discuss that. That is for expert committees to provide advice. There was no intention that our definition would cover this because the experts haven't discussed it yet. So there is no, we're not saying they're not planets. They're certainly not in our solar system. That's all the IAU is saying.
Alan?
Yeah, I'd just like to say two things in response to Jim's very good question. The first is that planetary scientists consider those objects planets. And they call them unbound planets simply because they're not bound to any star. The second thing I want to say, because I reviewed it this morning, and as Ron said earlier, the exoplanet community within the IAU has come up with a separate definition for planets around other stars. And that definition, which is quite lengthy and complicated because it goes into many branches, it's not very intuitive, specifically states that the IAU has no opinion, that that definition does not know what to do with, in other words, unbound planets. So what Ron just told you is wrong. There is an exoplanet planet definition, contrary to what he just said, and it excludes or doesn't speak to unbound planets.
Blue microphone. Please stand and tell us your name and if you're a member, Connor. No, blue. You're black.
Connor Nixon,
Sit
I'm
down.
a member of the Society. So my question is about moons. So under the GPD definition, many of the moons would become planets. Our own moon would become a planet. Many of the moons of, or some of the moons of Jupiter and Saturn, the larger ones would become planets. I don't see astronomers or planetary scientists voting with their feet and calling those planets right now. So do we need a new category for, are these planetary moon planets and the other ones are just planetary moons, or where do we cut that off?
Is that for me? Would you think?
That's
Yeah.
primarily for Alan, but I'd like to hear from
Why don't you go first, Alan?
Yeah, Connor, that's another great question. In the geophysical planet definition, the categorization of whether an object is or is not a planet is based upon its physical attributes and has nothing to do with where it orbits or what it orbits. So in fact, planets can orbit other planets, just as stars can orbit other stars, asteroids can orbit other asteroids, galaxies can orbit other galaxies. We call those, in the geophysical planet definition, satellite planets. It doesn't mean they're not moons. Moons is a separate category. It means something going around a planet. But in fact, the GPD already handles satellite planets and does so naturally with the same definition. Further, I could have brought a third recording taken from any of literally hundreds of planetary science sessions over the past few years, discussing planet-sized moons of the giant planets, and you would hear those referred to as planets by planetary scientists over and over and over. Even in the refereed literature, Ganymede and Io and Triton are oftentimes referred to as a planet or a planetary body. So again, the planetary science community is voting with its feet on this matter.
So if I can
Yes, please.
add to the answer, and I think it was a very good question, because it does illustrate a couple of things. First of all, IAU is not telling a bunch of specialists how to do their planetary science. That would be ridiculous to imagine that. But we are trying to tell the rest of the world what a sensible definition of a planet is. And I don't think the rest of the world would be comfortable with calling all these planetary satellites also planets. If you want to call them planets in your specialized group, that's fine. But I don't think the public would see that as a sensible answer.
Black microphone. Bob, question?
Sorry for jumping in. Bob Terry, I'm a member. And the question is to both the guests. Because this notion of clearing the orbit also seems to have something to do with these inner planets having the same circulation and rotation and having the same angular momentum as the sweeping gas mass that originated when the solar system condensed. It seems valuable to me to have a definition that recognizes that distinction. Clearing the orbit may not be good enough to recognize that distinction, and maybe one should think a little more tightly about what you want to have in terms of that distinction to designate planets that are essentially original bodies of the condensation of a planetary group. So I'd like to hear how you think that might fit in.
I've been
Or
first
not.
twice.
Oh, well, I agree with those comments. It is a useful attribute, and what the IAU tried to do was not talk to one branch of specialist planetary scientists, but a very broad community. And these are the kind of issues which are raised, and so it's our job to come up with a naming system which is international, which everybody's comfortable with. And because of issues of the origin of the solar system, the dynamical information is clearly hugely important, and why you would neglect the gravity but include the shape of the rock is a mystery to me.
Alan?
Yeah. The attribute that you like, the fact that objects' orbits respect the original protoplanetary disk, is as true of Pluto as it is of Mercury and all the other dwarf planets of the Kuiper Belt. Those are original objects formed at the same era as the closer planets, perhaps even earlier, and they orbit in the same direction with rare, very rare counterexample. Only those that have been flung out into strange orbits by Jupiter or the other giant planets. So in fact, the definition, what makes sense to you is precisely what the GPD is about, those same objects, planets.
Red microphone, please stand up, tell us your name if you're a member.
Yeah, good evening.
Kirby?
Kirby Runyon. I am a member of PSW Science. My question is for you, Ron. I think one way to summarize how Alan finished up could be encapsulated in the phrase, ignore the IAU, dwarf planets are planets too. And I'm wondering if you stand by the IAU's seemingly grammatically contradictory statement that dwarf planets are not planets, and if you do or don't, what do you think the IAU should do about that?
What I stand by is the process that the IAU went through. I myself, that's my personal opinion, thought that that was a pretty sensible outcome. But after a group of professional astronomers heard all the arguments, they thought it is only confusing to not make it really clear that dwarf planets are something quite different from the other planets. That was the view. We have a democratic process. And by the way, when you say the IAU has said something, IAU has a very formal process of making resolutions. It is a slow process. I said there was no resolution for exoplanets, and there is none. We are not talking about a society saying, here's a great definition of a planet. We are talking about a formal process which requires resolutions to make agreements. This is how international collaboration works.
I think I'll make 3 points. First of all, this slow and deliberate process that Ron is talking about took place in 5 days in Prague. So I don't think that that's a fair characterization of the generation of the current planet definition of the IAU. My second point is that everywhere else, even in astronomical lexicon, dwarf stars are stars, dwarf galaxies are galaxies, and dwarf planets should be planets. The last point I'll make, because I think it's very important and I want to try to crystallize on this, is that when astronomers, as non-experts in the field, try to impose a lexicon, a categorization, on something they are not expert, it's as backwards as if those neurologists that I spoke about earlier tried to categorize diseases of other parts of the body. Those other professional societies in medicine would say, wait a minute, back off, that's not your expertise. Stay in your fence lines for things you actually know something about in detail. And so go categorize black holes and galaxies and stars and leave the planets to planetary scientists. That's my view.
We have a question over here from Cameo Lance.
Hello, my name is Cameo. I am a member. For you, Ron, in particular, on the Q&A stage, you just mentioned to Alan that it's okay that he uses what definition he's comfortable with in his societies and his circles. Contradictory to the first 5 pages or so of what you were saying about how it is very important that you have an understanding of what you're saying with these words. So that, and the question that I'm asking here is the IAU willing to be wrong about their definition because of the usage of the scientific meaning and the classification that they tried to and are using in the science communities?
There would be a quite straightforward but lengthy process if, Alan mentioned a petition. The petition was never actually received by the IAU, so the IAU never responded to it. I don't know why that happened, but it didn't. And of course, you can, the IAU is not some group of outsiders. It is us. It is the community of astronomers' method of working together. And so if there is a case for changing it, then that could be put to the IAU. The IAU would have a resolution committee. It would consult with experts and decide if a change was warranted.
Forgive me, but I'm going to answer Ron's question in answering your question. The reason that planetary scientists never brought anything to the IAU after 2006 is we know it's the wrong group. It's made up of non-experts. Why would we bring the matter back to the people who, with all respect to their fantastic capabilities in astrophysics, botched the job to begin with?
Is blue out?
We're going to bring it forward in our own way. And in fact, the way that science is generally done is that individual scientists make up their mind about whether continental drift or the theory of relativity or quantum mechanics or the presence of an ocean inside a given world or anything else. They make up their minds one scientist at a time until consensus is reached. This whole process of voting is very abnormal in science. And as many times as Ron says it's not about science, in fact, miscategorization, because categorization is such an important part of so many scientific fields, from geology and biology to planetary science and chemistry, we really have to shy away from these techniques that involve raising hands and convincing the public that science is arbitrary, that by raising hands we could vote against global climate change, that we could vote against the theory of evolution, that voting somehow matters in science. In fact, it's all about consensus, reached slowly, painfully, and through the process of building evidence. That's how science really works.
So I would ask a couple of questions. First of all, Ron, it sounds to me like if somebody went through the right process, you believe the IAU would actually change its definition. But there's a possibility there.
Yes, of course.
And Alan, you're saying that you don't want to go through that process because the IAU aren't the right people to be making this decision in the first place.
Well, obviously, look what a mess this has been over the last 15 years or whatever it's been.
Well, if you could...
If I was an endocrinologist and neurologists made some pontification that affected classification in my field, I would not go back to the neurologists pleading for a better definition.
When Alan says it's a mess, just be aware that's Alan's view.
Yeah, we understand that.
That is not necessarily even the view of all the planetary scientists.
It's the view of look at the scientific literature. No one's using the IAU definition. Operationally, it's just a mess because it's in the textbooks, but it's not being used by the experts.
You made the point. Let's go to the blue microphone.
Hi, I'm Katie Gansler, and I'm a new member. This is a little bit of a turn, but it's for both of you. I know one of the reasons that New Horizons was such a big mission was that it was the ninth planet, the last planet that hadn't been visited. And I am hoping to go into science communications, so one of the reasons that New Horizons got approved was because it was a planet that hadn't been visited. How do we maintain the public's interest so science will be funded to send missions to other, I'm used to saying Kuiper Belt, that clearly is not correct, but other...
You could say planets.
Yeah. Well, not just planets, but other small bodies in the solar system.
Ron said he has no police force. Planets, and I don't think we would disagree.
Well, small solar system bodies, not necessarily even the GPD definition of a planet, but something like Bennu.
Should I go first? You want to go first? You know,
Thank you.
Most missions Most missions, or I'm not sure I've got the numbers right, but certainly many, many missions in planetary science go to locales other than planets. For example, missions to comets, missions to asteroids. NASA just selected in its Discovery program, which is the most frequent program to study our solar system by going to places, just selected 2 missions to different types of asteroids, totaling a total of $2 billion. And that's a very large investment for a very good reason, because those 2 particular missions are going to unravel big chunks of the story of the origin of our solar system. So I don't think that NASA's ability to fly things to different locales depends upon whether they're called planets or not. And I will tell you that even a decade after the IAU's botched job on planet classification, and all of the press it got and all of the textbooks that changed, NASA and our mission to, quote, non-planet Pluto had the biggest public response that NASA had seen in decades. I think because of several aspects of it. One, it was risky and daring. Secondly, everyone grew up learning about Pluto as the most distant outpost, and anything that's superlative, farthest, the fastest, is going to get attention. And then we discovered a heart on Pluto's surface the size of the state of Texas, and who could resist that? And so I think that what missions we fly in the future don't depend upon the politics of what astronomers say about planetary science. I think it depends upon the planetary science itself.
Do red microphone?
To even imagine that the naming process would have such influence indicates that there's a misunderstanding of what's going on. So of course, a dwarf planet is a fabulous thing to go and explore. There is no doubt about that. And I didn't put it in my presentation, but the IAU went to the trouble of saying there is a category of dwarf planets. They're really important. There's no question about that.
Red microphone, then the black microphone.
Hi, my name's Elizabeth Landau. I'm also in science communication, and my question is kind of a follow-up, actually. We have such an emotional attachment to the 9 planets, or dwarf planet, but anyway, of the solar system. You know, I think that there's so many strong feelings in the public about the fact that we all grew up learning about these giant worlds. And I guess my question to both of you is, what is your vision for people's understanding? Like, Alan, like, do you hope that children will learn all 100 and plus planets under your definition? And Ron, I mean, do you hope that they'll only learn 8, right? I mean, like, I guess I just wonder, like, what is your vision for taking your definition of a planet and then comparing it to other things when it comes to public understanding?
A very good question, and my view is that it is important that they understand there's a great difference between the 8 planets and Pluto, and it's important that they know that. It is round, it has geological features like other planets, but in terms of its gravitational effect, it is quite different. I don't think that's too difficult for children to start to understand, and so we make this a very positive message. There's nothing negative whatever. In fact, Pluto became its own class of object, not the tiniest planet in the solar system. It was upgraded.
Well, first I would hope that children don't learn that gravitational bullying is a good thing. And memorization isn't science. And we don't memorize all the elements in the periodic table to understand what the periodic table is about. We don't memorize all the stars in the sky to understand stellar astrophysics. We don't understand all the rocks and minerals just simply to think we know geology, because memorization is not science, right? Science is about physical properties, and it's, as I said before, ultimately a reductionist exercise in which you take masses of facts and try to make understanding of them. I would hope that in the 21st and 22nd and future centuries, that children learn that we've learned some amazing things at the dawn of the 21st century, that there's a 3rd class of planet in our solar system, that it outnumbers the other known classes. That doesn't diminish the other 2. It's just that the facts are there are more of them There are too many of them to memorize. So you might know the famous ones, like Pluto will probably always be famous simply because it was known even before there was a class, and because the only dwarf planet in the outer solar system to be visited, which we have real pictures of, not a fuzzy dot, is Pluto. But what's important is that the kids understand the big picture, that there are 3 classes of planet in our solar system, other classes of planets around other stars, that they don't have to memorize the names of anyone's but the famous ones, precisely like the rivers of the earth. When I was in 3rd grade, we were taught there were 7 great rivers like the Ganges and the Nile and the Mississippi and the Amazon and so forth. I don't think I can remember them anymore. But we didn't have to know anything else because you could just look it up in a book. You could look up every river on Earth in a book. And that's how the planets of our solar system and our galaxy will come to be. They'll be in the book of knowledge, and memorization hopefully will not be a part of curricula beyond the basic principle of knowing prominent examples.
Black microphone, Tim.
Timothy Thomas, I am a member. I'm curious about the timing of the decision. When the decision was made by the IAU, were things other than Pluto changed in category, or was this something aimed directly at Pluto? And if so, was it a hostility toward Pluto in some way?
So, sure, that's a good question. No, in fact, it wasn't triggered by Pluto at all. It was triggered by the discovery of what's now called Eris. It was the Mike Brown's Kuiper Belt object, which is a little larger than Pluto. That was the trigger. I can assure you there was no Pluto hostility involved in any way. In fact, it was interesting, after the meeting, there were many press there. And among the astronomers, and they're not planetary scientists, they're only professional astronomers, the press, especially the US press, was going around saying, putting a microphone in front of all these people, isn't it terrible what IAU has just done to Pluto? And they were very dismayed because they were saying, no, this is a very sensible thing to do. So there was certainly no hostility. Yeah.
I can't speak to the hostility thing. I wasn't in Prague because I spent that week putting my oldest child in college, and I thought that was a higher priority than going to a meeting of astronomers. But I do want to point out that the great flaw in all of this is that non-experts are making decisions about another field. Ron Ekers, fantastic and accomplished scientist that he is in cosmology and extragalactic astronomy, just told you a fact which is incorrect. We are now almost exactly 4 years since the exploration of Pluto by New Horizons, in which it was discovered that, in fact, Pluto is larger than Eris, the very object which started this debate. Ron just said 3 minutes ago that Eris is larger than Pluto. This is an incontrovertible fact, and it shows that you have the wrong field pretending to be experts in another field when in fact they step on it. I'll give you another example. When in his retort, he said that sea of objects that I showed in the video, actual objects orbiting in the solar system, were all resonant objects with the planets and therefore don't count as not clearing the zone. In fact, this is completely unso. I don't want to use the word true because I don't want to ascribe motive. But it's almost all of the objects across the orbits of the planets are objects like comets and centaurs and escaped asteroids, which are not in resonant orbits. They are field objects. The planets have not cleared their zone in any case. And by the way, a third statement that you made that's factually incorrect is that Pluto doesn't control the orbits of other Kuiper Belt objects. In fact, last year, in 2 published papers, that was shown to not be the case, that there's actually a class of Kuiper Belt objects which Pluto had specific dynamical effect on. So this is what happens when non-experts are pretenders to being experts in somebody else's field. And this is why the IAU is never going to be in a good position to get this right, because it's made up of people in the wrong field who are making guesswork
I think I'm almost forced to respond to that one. First of all, just on the factual issue, I certainly didn't intend to say that all those objects were in resonant objects. I know that's a small fraction. But I am not an expert. So Alan is trying to confuse you in some way by saying, because I'm not an expert planetary scientist, and I am not an expert planetary scientist, that we have no role in trying to work on international collaboration in science, which is what IAU is about. IAU is not about planetary science. I said many times, naming is not the same as doing the science. And so to smear me by saying, you know, I've got my planetary stuff wrong. Well, of course I have. I'm not an expert. He's the world expert. Of course he knows
But
this.
you are, and this is a debate, you are typical of an IAU member in that you are an expert in astrophysics and inexpert in planetary science.
So
what fraction of IAU members,
Yo,
Ron,
yo.
are actually planetary
Alan,
scientists?
Alan, let's tone it down a little bit.
I just want to know if Ron knows the fraction
We understand
of
your
IAU
point.
members that are experts in
We
planetary
do understand your point. We do.
Okay.
So let's keep it polite. Or I'll have to cut off the questioning and throw you off the stage. No.
Okay. Well, let's keep it polite.
I think the next question is the blue mic. Is that correct?
Good evening. My name is Mark Cockte. I'm not a member.
Polite question, please.
Polite question, yes. Directly to Ron, but Alan, you can weigh in if you wish, though I believe I will understand already your answer to this. Ron, you showed a graphic earlier with the dwarf planets and hypothesized ninth planet out there. If it's discovered that this is a fairly massive planet, but it's also discovered that it hasn't cleared its orbit, will it be considered a dwarf planet?
I use that example quite specifically because the fact that it has perturbed the orbits of these other Kuiper belt objects says that gravitationally it is effectively clearing its orbit. There would be no doubt it would satisfy the IAU definition.
I would just say that by that measure, the fact that Pluto is controlling the orbits of Kuiper belt objects around it, as discovered last year, would then qualify Pluto by the same measure. And the same for the other dwarf planets, by the way. I'm trying to keep this about the class of objects and not about a specific object that one spacecraft went to.
Please. Black microphone.
I'm David Evans. I'm not a member. And my question is for Ron. So you mentioned the gravitational influence multiple times. So is that a limitation of the resolution of our technology? So as we can see finer influences, will that change? And would Pluto, if we can detect that, even if it does affect Neptune, but it's very fine, will that then become a planet?
So when I discuss this with planetary dynamics experts, which I do occasionally to get opinions because I can't answer it from my own knowledge, the answer I get is the difference is so huge that this is not an issue. Maybe there is some minute perturbation, but the difference between the way the 8 planets control the neighborhood and anything else is so big that it should not be a matter of confusion.
I think we'll take just a couple more questions. I got the right red microphone back there.
Jim Murdoch. I'm not a member, but I'm interested. By the IAU definition, a planet has to orbit the sun, correct? The moon has twice the gravitation towards the sun than it does to the Earth. So wouldn't it be twice as accurate to say that the moon is orbiting the sun rather than Earth? In which case, the moon hasn't cleared its orbit, the Earth hasn't cleared its orbit, neither are planets.
I think that's for Ron there.
Your ball.
The intention is is no. The moon is a satellite. That's what we know it is. It's a moon, and we know what moons are. And so, in fact, you've got the headline definition. There were footnotes, one quite complicated footnote, which separates out the moons from a more difficult question is, you could imagine finding, maybe not in our solar system, but in some other star, a pair of planets of nearly equal mass in orbit around each other. Well, what do we call that? Is one a moon or is it not a moon? So this is where, new information would mean you've got to refine the definition in some way. And we would consult with the experts to find out.
So what defines a moon? Is it the primary?
No.
Sorry.
May I respond, though?
No, I want to go on to another question.
I don't get a retort?
Oh, you do get a report.
Yeah, I thought so. Thank you.
A reply, not a
reply. Thank you. Whatever, yeah. Okay, an R word. I get an R word. Okay, so I just want to say I thought that was brilliant because by the IAU's definition, the Earth is literally not a planet only because the Earth-Moon system actually orbits a common center of gravity orbiting the sun. And I want you to notice that again and again in what you've heard tonight, representing the IAU definition, you've heard apologies about, well, we didn't mean it quite that way, and it doesn't really work that way. Let me just point out one more. Pluto crosses Neptune's orbit. So doesn't that mean that Neptune hasn't cleared its orbit of Pluto? Just as much as it means that Pluto hasn't cleared its orbit of Neptune? This kind of sloppiness in science is not accepted. If I wrote a proposal to NASA or the National Science Foundation on this basis, I would be laughed out of the review panel, and it would tarnish my career. If I tried to publish papers with holes in them that you could drive a truck through, same problem. This is the way it is. Not talking about Ron, I'm talking about the IAU planet definition.
Keep the hyperbole out of this. Ron, would you like to respond?
By the way, Pluto is in a resonance orbit with Neptune, so I don't know much, but I think that is the case.
Neptune is in a resonant orbit.
No, I said Pluto is.
No, I said Neptune isn't. They're both resonant with each other.
Yeah. That means there is one controls the other.
However,
and you can say, you're trying to say Pluto controls Neptune? I won't buy that.
All right.
Did you know that Saturn is in a resonant orbit with Jupiter? Now, which one is not the planet?
Let us go. We're just going to have two more questions. The blue mic and then the black mic. Because of the time, not because of how much fun this is. Blue mic first, my friend with the blue shirt who refuses to join the society.
Will Angel, not a member yet. A question primarily for Alan, but I look forward to Ron's response. Is there any way that the process could be redone that would make you happy for the IAU defining a planet, or are we beyond reconciliation now?
I don't think it's about reconciliation. I think it's about the way that science really works. From my perspective, science really works by scientists coming to consensus in the literature about what works and what doesn't work. And the process of committees and organizations voting is just, it's not science. And I don't know how the IAU got it in its head that it owns planetary science, but clearly it doesn't, as demonstrated by planetary scientists who, when publishing papers and giving professional talks in front of their own peers, never use this definition, or essentially so rarely use it that it can't be found in the literature.
That didn't really answer the question. Ron, care to respond?
Oh, yes, I was just reminded of the fact that the reason IAU consulted the experts, I put the list of options which were generated by 2 panels of experts, and Alan is clear on what his definition is. Experts, in fact, have not been able to come up with a clear definition, and that's because it isn't science, and that's where IAU has a role to play, and that's why you take a vote. There's not a right answer and a wrong answer. You need a consensus, and you use a vote.
Last question, black microphone in the back.
Hi, my name is Stephen Mortler. I'm not a member. My question gets to maybe an area where there's the conflict between the two fields of expertise of astronomy and planetary science might be a little bit more pointed, which is, I noticed that neither definition takes into account the formation of the body. And my question, and I'll direct it to Ron first because that definition claims to cover exoplanets as well. Do objects that form like stars but actually don't produce nuclear fusion, like brown dwarfs or sub-brown dwarfs, should those under that definition of the geophysical definition, are those counted as planets, even though they formed similar to how a star would form? And do you think, both of you, should those objects be counted as planets, or should formation be incorporated into definitions?
So the IAU answer to that would be that hasn't been considered by the IAU. There is no resolution, there is no definition. It's still an open question to discuss among experts. We don't, you know, this definition, I said it a number of times, it was quite specifically in order to go ahead with the naming system of objects in the solar system, we needed an agreement on this in the solar system, and that's what it was about.
And with that,
So do I get to?
I'm sorry.
to
I'm just
respond?
a little ahead of
Is that an R
myself
word?
there.
Yeah, I think that I'm speaking for myself, but I also have spoken with many planetary scientists who don't like the idea of convolving origin with categorization of object types, because as we learn more and more, and we know light years more, sorry, that's an astrophysical term, but we know light years more information than we knew, let's say, at the birth of the space age just 2 generations ago. And our ideas of how planets form and how small bodies, planetesimals, formed have so radically changed in the space of 50 years that we believe it's likely that with the discovery of hundreds and now thousands of examples of exoplanets, and that's only going to multiply, that our ideas of origins are going to continue to mature and radically change as they have. And for that reason, any categorization system based upon that, categorizing types of objects on the mode of their origin, is likely to look quaint and be severely outdated by the data 10 or 20 or 30 years from now, so it's unstable. And it's simpler to do what we do elsewhere in other fields, is categorize based simply on an object's attributes that are verifiable and not later refutable, like whether an object is rounded due to self-gravity.
Well, thank you both.
What do you say?
Hold it up. Before you go, I'm going to present you with these
Here you go.
glass of water. Sorry. This is an odd problem that comes up without warning. So I want to present you with these plaques, these framed copies of the announcement of this debate, signed by all the members of the General Committee on behalf of the membership as a whole. And I will also present you later with a signed copy of Volume 1 of the PSW Bulletin, so you'll have something to do on the airplane ride back home.
Thank you very much.
Before we go, you guys can go. You guys have to stay because we're going to have a vote. This will be very interesting. Take out your phones. This is the only time you're allowed to take your phones out at the Cosmos Club. So please, avail yourselves of this rare opportunity to break the rules. So if you'll take out your phones and call up a browser, and you folks online can do it too, and go to www.psscience.org. And you will find at the top of the screen, on the home page, the banner. I mean, it's hard to miss, you know, it's right there. Oh, come on, down there, that banner, and click on the text, and it will call up a question. Indicate based on this debate if you prefer the IAU planet definition or the geophysical planet definition. You check one, I'll give you a few minutes, and then we'll call up the screen, hopefully, and we'll see how people voted. So how many of you are voting? Raise your hand. Okay, only people who vote can have the refreshments afterwards. I'll know, too. Actually, it's an anonymous vote. I'm going to give people a couple of minutes. Well, be patient, keep trying. We'll give it a few minutes. Hey, Jared, what's the problem? Well, Alan wanted an anonymous vote. If anybody succeeds, raise your hand. Okay, so let's just be patient and keep trying, and eventually, you know, some people will be able to vote 5 times, and some people will only be able to vote at all. It'll be just like a, you know, a good election that we have sometimes, right? Of course, voting is not how you're supposed to decide scientific issues. Yes, you have to keep trying. You have to keep trying. I'm sorry? You must keep trying. As the I Ching says, perseverance furthers. Let's see. Well, so far we have 53 votes for the Geophysical Planet Definition and 13 votes for the IAU. You have to keep trying. Your vote doesn't count, okay?
You mentioned you had over 350 viewers online, and Robin said you can also invite people to join the society.
Well, I'll get to that. It does say IAU Planet Definition Ekers and Geophysical Planet Definition Stern. So the one on top is the IAU in green, and the one on bottom is the Geophysical Planet Definition in blue. So it would seem to be that in this particular vote, there is a clear preference for the Geophysical Planet Definition. And assuming that it's mostly people in the room who are voting, almost all of you have been able to vote. But I'll give it a few more minutes. Anybody who logs onto the website and hits that banner can vote, yeah. So I don't think that the outcome is really going to change when the absentee ballots come in. We're not done yet. Please quiet down back there. Excuse me, we're not quite done. So these are the results so far. I think it's pretty overwhelming that the particular voters of this particular ballot are in favor of the Alan Stern championed geophysical definition of planet. And the number keeps growing. All right, so before we go, I do have to make a few closing announcements and tell you who the upcoming speaker is. So PSW depends on members and sponsors, and if you're not a member, including all of you who are watching online, which I understand is about 400, please consider joining. And if you are a member, by the way, that's you in the blue shirt there. If you are a member and you have not yet paid your dues, please pay your dues. And if you have paid your dues, please consider giving an additional donation, sponsoring a lecture or even a series. And think about volunteering to help carry out the society's activities. We don't have any paid staff. Everything that's done here, from me standing up here to getting speakers, to posting information on the website, to running these cameras, to doing the live stream. It's all done by volunteers. And so if you have any expertise in the area of video or video editing, in the area of website development and content, please see me or our streaming director back there hiding behind the audio rack, or our recording secretary, James Heelan, or our room manager, Savannah Crawford, or me. And I'd like to talk to you and see how you can maybe chip in to keep these things going. For those of you who are not members, let's see where we are here. We're getting up into the 80s. Can you read that? It's 85 to 20. So we have 105 votes. So I'm going to get out of this for a minute and go back to this. If you are not a member, you can join. It's very easy to do. You just have to go to the home page, which if you voted, you just did, and go to the join button, which will pull up our membership application form, which will pull up our membership information form. If you'll hit on this hyperlink, it'll pull up our application form, which you will fill out. And when you hit the submit button, it'll ask you for money. And when you pay your dues, your application for membership will be forwarded to a general committee and considered a due course. And if you have a genuine interest in science, you will be admitted to membership. If, in the unlikely event, you're not admitted, and it is a very unlikely event, we will refund your dues. PSW is a nonprofit educational organization tax exempt under Section 501c3 of the Internal Revenue Code. Contributions are tax deductible to the extent permitted by law and the Internal Revenue Service. All PSW members in good standing can wear the PSW rosette, the blue one here. If you wish to purchase one as a member, they're $15, and you may do so at the table in the back of the auditorium. We are coming to the end of the spring lecture series, which culminates with the annual Joseph Henry Lecture. This will be the 18th annual Joseph Henry Lecture, and it will be on May 17th. The speaker will be Brian Keating, and he will be speaking on the Big Bang and inflation, glimpsing the beginning of time from the ends of the Earth. Brian is the PI on BICEP 2 and director of the Simons Observatory. He searches for predicted anisotropies in the cosmic microwave background. He was the PI on BICEP 1, which thought it had seen those predicted anisotropies, but as it turns out, had not. So he wrote a book about it. And the book is called Losing the Nobel Prize. And it's a very interesting book. I commend it to all of you. The lecture will be sponsored by Millen White, Solano, and Brannigan, which is the law firm where I work. And that will be the end of our spring lecture series. We'll be back in the fall. I want to recognize and thank the PSW volunteers who make these events possible with their time, hard work, creativity, and commitment to PSW, and it is quite a commitment. So please give a big round of applause to Brett, Jared, Dan, Savannah and Cameo, Noah, James, Lloyd, and our red, blue, and black mic runners. Thank you very much. The social hour ends promptly at 10:30. Please use the side entrance to exit the building. And I will now entertain a motion from a member to adjourn the 2409th meeting of the Society to the social hour. A second? All members in favor? Aye. All members opposed? Nay. Throw that person out. The meeting is now adjourned to the social hour.